In this lesson, we will learn about the oldest and most common Wi-Fi security protocol defined in IEEE 802.11, the Wide Equivalent Privacy or WEP. The core component of WEP is the static WEP key, which is entered in the form of hexadecimal characters from 0 to 9 and 1 to F, or ASCII characters. Some clients and APs support the use of up to 4 separate static web keys, from which a user can choose one as the default transmission key. In this example, as you can see, we can define up to 4 keys, and in this configuration, the key number 1 is chosen as the transmission key, and here is the key value, and it has a size of 128 bits. The static key is pre-configured on APs and clients. The key is then used by the APs to authenticate the clients before granting the access. After that, the clients and the APs can use the key to derive other mutual agreeable encryption web keys. A web key can be 64 bits or 128 bits, in which 24 bits are used for initialization vectors or IV. The IV is sent in clear text, and a new IV is created for every frame. As you can see in the 64-bit web key, 40 bits are assigned to the static key, and in 128-bit web key, 104 bits are assigned for static key because 24 bits are used for initialization vector. Here is how web performs the access control. As you may know, the client and the AP use the same web key. Before allowing the client to join, the AP sends a random challenge phrase to the client. In this case, the challenge phrase is access. The client encrypts the challenge phrase with the web key and returns the ciphertext to the AP. And here is the ciphertext from the client. The AP also encrypts the challenge phrase using the same web key, and here is the ciphertext from the AP. Upon receiving the ciphertext from the client, the AP will compare with its ciphertext. In this case, it is matched, therefore the AP will allow the client to join. Before performing the encryption, WEP first generates the integrity check value or ICV for every data frame. Here is how it does it. As a transmitter, WEP runs a cyclic redundant check or CRC on every plaintext data, which generates the ICV for every data frame. The ICV value is then appended to the end of the plaintext data for encryption. Next, a new 24-bit cleartext IV is generated for each data frame and is combined with the default transmission static web key to create a seed. A seed is processed by ARC algorithm to create a key stream. The key stream is then combined with the plaintext and ICV by using Boolean sort process, which creates the encrypted data. The encrypted data is then prefixed with the key number of the default transmission key along with the cleartext IV. all of which are sent over the air to the receiver. Here is how WEP performs the decryption. As the receiver, WEP extracts the key number, which allows it to know which key is being used and gets the corresponding value of that key in its configuration. WEP then extracts the 24-bit IV that it received. Next, WEP combines the WEP key and the IV to create the seed. The seed is processed by ARC algorithm to create the key stream, which is the same key stream used to encrypt. The key stream is combined with the ciphertext using the solve process, which produces the plaintext and the ICV. WEP then runs the CRC32 on the plaintext to get the ICV2. The ICV2 is now compared with the ICV that it received. If matched, then the data integrity is confirmed. Finally, let's look at the solve process. To understand the solve process, we need to know the solve truth table. And here is the data string that we want to encrypt. And here is the key stream generated by the WEP process. Here is the encrypting process, and we put the data in with the key stream, and we get the ciphertext using the source process. To decrypt, we put the ciphertext and we use the same key and we get the data back.